So we are practice test, chapter 6, on we go. I would briefly revisit the first 83 if you want me to, but we just did that yesterday and recorded it, and anybody can watch that if they wanted to from the 610 video. Is there anybody that wants a quick answer or two while we're here and save yourself a video watch? We'll put all that bonus in play. I don't really want to run through the ions today either, but the ions, we would do all 47 of them that we've been doing, but include the names. That we haven't done the names for a little while. So 61 point page there, and that's the next day up is that. Question about any of that? Nothing for clear? Quick and easy. So then we go problems. Here we go. The problem group, I think, is 3 points per problem. So I believe this test is a 165 because there's 55 answers times 3 points apiece. But I can confirm that, but I'm pretty sure the syllabus would say how many points it is. But for number 1, what's your key to number 1? Which number? Which atom? Oxygen is generally -2, and it is in this case. We did not do in the homework, we will not do on the test, any of those exceptions. Those rules had exceptions, we're not going to do those exceptions. So O you can commit as a -2. So I wrote kind of like down under the O and -2. Who else is a foundation for this? 1 for hydrogen. So next to hydrogen, we'd write a +1. So those are your building block cornerstones. Label the O, label the H. And then, like, do 7th grade math with positive and negative numbers, because it's supposed to usually add up to 0. So to make it happen, Br must be a +1. So +1H, +1 Br, -2 for O. 2, do the same thing. The O is, again, a -2. But take into account when it comes time to do the math that there's 2 of them. But don't write down anything about -4. No. We're writing down a -2 for the O. H, we're still writing down a +1. And then when we do the math, take into account 2 of those -2s, a +1. What does N have to bring us? A +3. If you want to use your periodic table at all for a small check, the periodic table can tell you the maximum oxidation number, but it can't tell you the actual number. Nitrogen's in column 5, so you can't go above 5. So if you did math and it said nitrogen is 6, and you're in column 5. 3, small change of the game. What's the small change of game in 3? The little power looking thing is telling you we're not adding up to 0 anymore. We're adding up to -3. So O continues to be -2, but with 4 of them, for the math to work, the AS has to be a +5. 4, we're back to adding up to 0 again. The O is a -2, but there's 7 of them, so -14 in play. H is a +1, but there's 2 of them, so we're back to -12. For bromine to get, or boron to give you the +12 offsetting total, we've got to go with B with +3. 5, we're not adding to 0, we're adding up to -2, so the O continues to be -2. There's 4 of them, so we're a -8 total on the negative side of the problem. So what's the Mn bringing you? A +6. Anybody need help with those?
Can you explain number 4 again?
Number 4 again, the O is -2, so 7 of them gets us to -14. H is a +1, so 2 of those moves us up +2 from -14. We're now at a +12 total. So the B has to give us we're at a -12 total. And then the B has to give us +12 with 4 apiece. 4 of them, 3 apiece. You all right?
Yep.
Anybody else want to find? 6, 7, and 8, we're trying to do some diagrams of nucleus and whatever. So let me do 8 on the board because that's the biggest one, and then I'll double back to the left for some simpler ones. So for 8, what's the 16 do for you? Tells you 16 protons. Where do those live?
Inside.
In the nucleus. So 16 protons in there. Who else is in there? neutrons. How do you know that the 16 is the number for neutrons? You subtract the 32 minus 16. And it might or might not be the same as the proton number, but it's generally at least in the same ballpark. How do you know the electrons on this one? Same as protons usually, but in this case it isn't 16. It's how much, team? 18. How 18? The 2 minus gives us 2 more electrons. So we need an 18 electron count, but we do these in levels. So the first level holds 2. The second level holds 8 more to get to 10. And then if we're trying to get to 18, we need 8 more in level 3. If I go higher than that, you're going to have to think about this old frenemy, because this tells you level 1 fills before you touch level 2. And level 2 fills before you touch level 3. But when you get to level 3, we're like filling some 3 before we go to 4 and come back to 3. 18 electrons takes you to this point. 2 plus 2 plus 6 plus 2 plus 6. We're up to 18. So if we go beyond 18, like this starts to come into play. What was your question?
No, I was just.
Okay. So more than 18 electrons, you need this. Under 18 or under, you don't need this at all. So 7, we don't need that at all. 7 inside, we'd have 12 neutrons, 12 protons. What is your electron count supposed to add up to on 7? 11. So we'll go 2, 8, 1 on number 7. Back to number 6. Inside, we'd go 4 proton, 5 neutron. And then how many electrons are there on 6? Just 2. So put them in level 1 and call it a day. Question about 6, 7, 8. 9, as soon as it says sublevels, that's all about this. This is sublevels. Anything ever that says sublevels all year long. There we go. So first we need an electron count. So for number 9, it's how many electrons? 2. Because we go off of the 3, but if there's a positive charge, that means one of the electrons went away. So we're going 2 electrons. So that's 1s. Does the 1s hold 2? Yep. So 1s2, and that's it. 10. How many electrons? 18. So that's the path we already talked about traveling to there. So we go 1s2, comma, 2s2, 2p6, comma, 3s2, 3p6, quit. Something there. 11. Electron count? 36. So S's hold how much? 2, so we'd be up to 20. P's hold 10, so we're up to 30. P's hold 6, so we're up to 6, and that's where we're stopping to get our 36 electrons. So just fire it off. It's the same beginning as 10. 1s2, comma, 2s2, 2p6, comma, 3s2, 3p6, comma, 4s2, comma, 3d10, comma, 4p6, get out. Question anything about up to 11 before I erase this to have space to do more work? 12 is the easiest question of the test. You just have to copy the number back down. So 3.42 times 10 to the third joules, just copy it back down. However many joules it takes to make a bond, it's the same amount of joules to break the bond. Just copy the number. 13, the nitrogen is going to get the symbol with the minus. The hydrogen is going to get the symbol with the plus. How do you know? Yeah, we could use the list of electronegativities for one. So since nitrogen is higher on that list, that means it wants electrons. So we'll go minus on that and plus on the other one. That's the simplest way I think to do that. I'll give you the chart from the 0.7 to the 4.0. Yep. So chlorine, plus or minus, is the plus, oxygen's the minus, because oxygen's higher on that list. Something about 13, 14. 15, do some dots. So 15 central has to be nitrogen. How do you know how many dots? Chart. It has 5. So 1, 2, 3, 4, 5. Doesn't really matter how you set them up, but you get single, 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 and double on 3 of the sides. Then if we go to build in the hydrogens, hydrogens each come in building with 1. So based on the way I set this up, I would need 1 on the top. Do maybe like a circle or something, so I can tell that it's a different kind of dot. Hydrogen circle, something like that. Any issues? Nope, that's a winner. Question about, that's the Lewis structure. Structural formula, what am I doing about this?
And in the center still.
And in the center still.
And then one line going up to hydrogen, one
Okay,
line
up to a hydrogen,
down to hydrogen.
maybe.
Right or left.
What kind of thing though? I'm gonna go dotted, like shaded in 3D thing. And then 2 of these are also gonna take hydrogens, and one of them is the dot pair. And what is that called? That is pyramid.
I thought this, so you want us to draw the shapes on there?
I thought it was just the lines.
Yeah,
Structural
formula
formula.
means the lines.
I'm gonna say maybe it does mean that, but I wanna just go all out.
Okay. So if we just do the lines, then we would get it wrong, so
Yep.
that is what we have to do.
Correct.
Okay.
At the time we first learned structural formulas, that is exactly what we did, was just those lines. But we've done stuff since then, and in my mind at least, we've supplanted that knowledge with something better. Harder, but like a better descriptor. Something to 17.
Never mind, we're gonna answer this in a second.
Okay.
But
18, I'm going carbon in the center, probably because the electronegativity is 0.7 to 4.0, it would probably tell me so. But common sense tells me if I have 1 C and 2 S's, like,
The C is gonna
C's
go.
gotta go in the center to have some kind of symmetry to this. Carbon brings in 4, so if you try to do this, you're creating a mess. Because sulfur only comes in with
6.
6. And so 6 and 1 can't make 8 over there. 6 and 1 can't make 8 over there. So the solution is
double bond.
double bonds. And move these electrons from the top to the side. And then come in and use some sort of other punctuation on X's or circles or something. So that what I can see is sulfur brought 6, carbon gave 2. Carbon gave 2, sulfur gave 6. There's a symmetry to that. So carbon has its 8 now with this double bonding. Sulfur has 8. Everybody's got 8. Everybody's a win. And we're good. Question about that. So a later question, who had a double bond? Well, 18 is in the running. Maybe there'll be more, but 18 double bonded at least. Structural formula. Here we're just doing the lines because we never supplanted that with anything 3D. Linear still just looks like what it always looked like. Spoiler alert, I gave away linear. Something there. Am I still viewable if I go to here, or should I erase?
Oh, you're still good.
So 21, you can check the electronegativities, but realistically, there's 1 nitrogen and 3 oxygens, so it's going to be nitrogen as the central. Nitrogen is bringing 5, so that seems light. So I'm a little suspicious that nitrogen with 5 is going to come through for me if I do something like this. But I'll just do that to get, I got to get something started. Each oxygen comes packing 6. So 1, 2, 3, 4, 5, 6. That looks decent. 1, 2, 3, 4, 5, 6. 6 is short. 1, 2, 3, 4, 5, 6. That's short. So, do I have any wild cards?
Yes.
I do have one wild card, so I could play that like somewhere,
And then you double bond the other.
but I've got to double bond somewhere else because I just ran out of puzzle pieces. So my solution is this X should be more out. That should be more in here. This is in there. I've got a double bond hooking in that direction. And now that's a win. Everybody's got 8.
Double bond. Because oxygen brings 6, and nitrogen brings 5. If you just put 2 on nitrogen on one side, and then you finish it with 6 for oxygen, put 2 of the nitrogen on the other side, do 6 of the oxygen, then you have 1 with the oxygen on the third side, the 6 of the oxygen, and the 1 remaining. You just have a blank empty side. I don't have a double bond.
Because that is 5.
Yes, but
Where is
I was so confused.
So no.
No, I was so confused.
Something there. Shape or drawing, that's a trigonal planar. So we go nitrogen and kind of spread those out. And on one of them, it doesn't even matter.
Add 2 lines.
Throw a double bond. Go something like that. And then there's one more little technicality on this one. I'd like to go like this. Just tell you it had a negative charge.
Stupid.
Something about 21.
Would we get it wrong if we didn't put those parentheses in the?
I'd probably go like half point or something. I'm not going to go -3 over that. But that would cost you something. So add that to our list for 30. Double bonds, also number 21. 24. Back to where I came from. So 24, sulfur's got to go in the center, either because of the electronegativities or just like, obviously, if we're getting 4 oxygens in play, we've got to go oxygen to every side. Sulfur comes bringing 6. So double, double, single, single. Oxygens come in bringing 6. So the top works quite naturally. And the bottom, the way I did it, works quite naturally to get us up to 8. For the sides, 1 in and 5 more out would be my first lean. 1 in and 5 more out is my next lean. And then I hope and pray that I have 2 wild cards because I got 2 empty spots.
And you do.
And I do. Hooray for wild cards. So the wild cards also have to go to the outer edges of stuff, never like in the center. Not the way that goes. Something about that.
Do we have to make the wild cards distinct or different too, or can we just?
Yeah,
have one?
I should see 3 different things. I should see dots that I can tell came from S, dots that came with O's, and dots that came in as the wild cards. So do either use color coding or use dots, circles, X's, triangles, like just different whatever symbols you got it, whatever you got to do. Shape on this. It's tetrahedral, and it would be the exact drawing that I just erased, so I should have left it there, but it's the same drawing basically as the nitrogen drawing for number 15. The S in the center and surround it with all that 3D dotted line stuff, and then we get the brackets around that with a 2 minus. Something about that. H2O I use because that's about the simplest one I can do that's going to give me a shape with bent. So O is in the center, 1, 2, 3, 4, 5, 6, spread them around. It doesn't matter where the singles go, but the way I did this, I have to tack a hydrogen on the left, and I have to tack a hydrogen on the right. And that's the Lewis structure. Structural formula would look just like number 15 looked, just with an O in the center, 2 H's scattered around with 2 of those electron pairs scattered around, and as I said, it was bent. So if this were the test, you'd get 3 points for triple bond saying, never on this paper, but maybe the test does have a triple bond.
How is that bent and not,
Because it has 2 sides with the electron pairs without elements. If there's elements on 2 sides, that's bent. If there were an element on 3 sides, that's pyramidal. If there's an element on all 4 sides, that's tetrahedral.
no, I meant how is the bent not, linear?
Because it has things on 4 sides. Oxygen has things on all 4 sides. The one that we did linear, was it the CS2?
Yeah.
There were no electrons in those 2 positions. The electrons were in a line. Whereas this,
On top.
the electrons are all 4 sides.
Okay, thank you.
Yep. More to 31, anything?
What was the name of the picture on 24?
24 was tetrahedral. That's when there's elements on all 4 sides. They're all considered like a tetrahedral family, but pyramidal and bent is a more like specific name for a tetrahedral like special case. So 31. To the back. What you're going to want to do on 32 is find charges either from your memory or from your periodic table. And to create the subscripts, you just do like swapsies of these charges. In other words, magnesium is a +2 because it's in a column that gives it 2 electrons. Chlorine is a -1 because it's in a column with 7, so it wants an 8th electron. And you take the 2 and the 1 and just play switchies. So the formula would be MgCl2 with the 2 as the subscript down under around. 33 would be FeBr3. 34 is a Ca3P2. 35 is Ba. And then you need parentheses because nitrate, the entirety of nitrate needs a subscript. So we need to wrap NO3 up in parentheses and then have a 2 after the parentheses cut.
Was it 2 go up top or at the bottom?
It's at the bottom, so I'll draw that. So we've got Ba had a charge of 2. Nitrate has a charge of 1. So with a charge of 2 and a charge of 1, I need 1 of these, 2 of those. So to make 2 of these, that's how I make 2 of those.
Okay.
36 is AlPO4. Those fit together perfectly with their 3 charges, so hooray, we didn't have to. 37 is what we were talking about when we noticed the camera died. SN, and then in parentheses CrO4, and after the parentheses cut, O2. 38, I would give you the periodic table with the oxidation numbers on it as well. So you would just grab a +2 off of that. 39, you do 2 because it's a nonmetal, so nonmetals have 2. So 39, I'd want both a +5 and a -3. 40, we're playing math pattern games. We want to come up with a 3.66. Does anybody need help up through that?
Well, I get like 37. Is it just the whole number? It's the simplest whole number ratio by being about 4.
Yes, correct. Because if you did 2 versus 4,
It just evens out. Okay,
it's
so
like a fraction reduces. Yeah, that is exactly correct. More to 40. Okay, 41. We're just trying to spot who's in whose column. So sodium is in column 1. So down below, there's somebody else who is in column 1, which is rubidium. So 41 is going to be kind of like the Na2SO4 formula, just do swapsies. Before you make complete swapsies, though, you should make sure that selenium is in the same column as sulfur, which it is. So then we're just going to mimic the way the subscripts work and the way the oxygens work and go Rb2SeO4. So then we're examining magnesium, which is in column 2. So we look for somebody else who's in column 2, and that is barium. Before you fully commit, you'd want to make sure that the phosphorus is in the same column as arsenic, which it is, and then we just need to do number 43 by mimicking the numbers. So it's Ba3, and then the parentheses have ASO4, and then a little 2 afterwards. And then that probably gives away that the aluminum thing is going to do number 42, but I would check it just to make sure I didn't either make a mistake or mess with you. Aluminum is in the same column as whatever is indium, and then oxygen is in with selenium, so just do the switchy In2Se3. Something about that switchy game. 44 is, well, let's do the rules first. What's one of the rules that makes something ionic? Ternary. So that's the easiest rule. That's the easiest one to spot. Who's that? 47 is ionic, and because it's ternary. What's another rule?
Metal and not like oxygen or fluorine.
Yeah, oxygen and fluorine with a metal. So who is that? 46. 46, we've got silver with oxygen, so 46 is ionic. And then the third rule is the crazy one.
Column 1A, not H, or column 2A with 6 S or O only, and then 7.
Yeah, isn't that a fun rule? So who is that one? 44. 44 is column 1 with column 7 and didn't do any of the exceptions, so 44 is ionic. 45, even though it is column 1 with column 7, why is it covalent? Because it's hydrogen, that was the exception. And then 48, just not even in the running of anything even close. That's just straight out covalent.
Because the S is in the right column, but it can't be S.
Right. Correct. Yeah, and but C's not in the right column. C's in
Yeah.
column 4, and that's not even in that game. Then periodic table usage, you would just count up to where would 117 fall. So it would be in
7O.
7A. So valence electrons would be 7. The thing it most would resemble
18.
is AT, because AT is directly above it, is where we would always look for who its most similar friend is. Metal or what? Metalloid, because the step line would be touching that box. Charge on it is -1. Bigger or smaller? Bigger, because as you go down, everything gets bigger. And then if we go research sodium, sodium has a charge of +1, so the symbol would be big N, little a, and then a big old X. So, Nats. Questions, anything, anywhere, anything about problems, test, stuff? Boy, there was a lot of different types, but no single one of them was really like super hard, I didn't think. But there was a really, really lot of variety in this chapter. Questions there? Shut that.